Imagine a planet so scorching it outshines most stars, a world where the air itself evaporates into a glowing tail of gas, trailing through space like a cosmic comet. This is KELT 9b, the hottest known exoplanet, lurking 670 light-years away in the constellation Cygnus. With a dayside temperature soaring to 7,800 degrees Fahrenheit, hotter than the surface of some stars, this gas giant defies everything we thought possible about planets. Orbiting a blazing blue star twice the size of our Sun, KELT 9b completes a year in just 1.5 days, locked in a fiery embrace, so close it's being unraveled by its own star's fury. How can a planet survive such hellish conditions? What secrets does it hold about the universe's extremes? Discovered in 2017, KELT 9b has captivated astronomers with its sheer oddity. It's not just its heat that stuns. Its atmosphere puffs up like a balloon under relentless radiation, and its orbit tilts wildly against its star's spin. In this documentary, we'll journey into the blazing heart of KELT 9b, exploring its discovery, its bizarre nature, and what it reveals about planetary survival. From the minds behind its detection to the cutting-edge telescopes probing it today, we'll uncover why this world matters. Is KELT 9b a glimpse into the fate of gas giants, or a fluke of cosmic chaos? Strap in for a ride to the edge of the imaginable, where the line between planet and star blurs in a blaze of wonder. To understand KELT 9b, we need to rewind to the dawn of the 21st century, when the hunt for exoplanets, worlds beyond our solar system, ignited a scientific revolution. By the early 2000s, discoveries like 51 Pegasi b in 1995 had proven planets could orbit other stars, detected via the radial velocity method, which tracks a star's wobble under a planet's gravitational pull. But it was the transit method, watching stars dim as planets cross their faces, that truly opened the cosmos. Enter the kilo-degree Extremely Little Telescope, KELT, a modest pair of robotic telescopes launched in 2004 by a team from Ohio State University, Vanderbilt, and Lehigh. Unlike NASA's Kepler, which stared at faint stars, KELT targeted bright ones, scanning the sky for massive planets. In 2017, this persistence paid off. A team led by astronomer Scott Gotti announced KELT 9b in Nature, revealing a world unlike any other. Orbiting KELT 9, a blue A-type star 2.4 times the Sun's mass, this planet was spotted during a transit that dimmed its star by a mere 0.7%. Follow-up observations with the Spitzer Space Telescope and ground-based spectrographs confirmed its existence. Gotti recalls, "When we saw the data, we knew we'd hit something extraordinary. It was too hot to ignore." KELT 9b's discovery built on a lineage of hot Jupiters, gas giants orbiting perilously close to their stars, like HD 189733b, found in 2005. But KELT 9b took extremes to a new level, its temperature rivaling stellar surfaces. The science behind it traces back further. In the 19th century, Joseph Fraunhofer's spectroscopy laid the groundwork for analyzing starlight, later adapted to study planetary atmospheres. By the 2010s, instruments could detect vaporized metals in exoplanets, a key to understanding KELT 9b. Its host star, KELT 9, burns at 10,170 K, a blue giant nearing the end of its 300 million-year life. This system likely formed 4 to 5 billion years ago, with KELT 9b migrating inward from a colder orbit, a process theorized by astronomers like Fred Raisio. KELT 9b's story is a triumph of collaboration and technology, from humble telescopes to the legacy of Kepler and beyond, revealing a universe where planets push the boundaries of possibility. Let's plunge into the blazing core of KELT 9b's story, unraveling its secrets through 3 searing chapters: its formation and structure, its extreme environment, and the science of its disintegration. Chapter 1. Forged in Stellar Fire. KELT 9b began billions of years ago in a swirling disk of gas and dust around its massive star, KELT-9, a blue A-type giant 2.4 times the Sun's mass. Likely born farther out as a typical gas giant, it gathered hydrogen and helium into a vast envelope, growing to 1.89 Jupiter radii, twice Jupiter's size, but with just 2.9 times Jupiter's mass. Its density, a mere 0.68 g/cm superscript 3, hints at a puffed-up structure inflated by relentless heat. How did it get so close? Planetary migration offers the answer. Dr. Fred Raisio, an expert in orbital dynamics, explains it likely spiraled inward through the disk, dragged by gravitational friction. Orbiting at 0.0347 Australian dollars, 25 times closer than Earth to the Sun, it completes a year in 1.48 days, tidally locked with one side forever facing its star. This proximity shaped it into a hot Jupiter unlike any other, its origins a testament to the chaos of young stellar systems. Chapter 2. A World Beyond Hot. KELT 9b isn't just warm, it's infernal. Its dayside temperature hits 4,600 K, 7,800 degrees Fahrenheit, hotter than most stars and only 1,000 K shy of the Sun's surface. This heat comes from KELT-9, burning at 10,170 K, bathing the planet in ultraviolet radiation 56,000 times stronger than Earth receives. The result? An atmosphere that's evaporating. Hydrogen boils off at 1 Earth mass per billion years, forming a glowing tail detected by Hubble in 2019. Spectroscopy reveals vaporized metals, sodium, magnesium, even iron, floating in its haze, a phenomenon unseen elsewhere. Dr. David Singh, a planetary scientist, marvels it's like a planet turning into a star. Its atmosphere is a molten soup. The night side, cooler at 2,500 K, still glows faintly, a stark contrast to the dayside's inferno. With an albedo of 0.4, it reflects some light, but most is absorbed, fueling its balloon-like size. KELT 9b redefines hot Jupiter, a world where chemistry itself melts under stellar fury. Chapter 3. The Edge of Survival. KELT 9b's orbit is a death sentence in slow motion. Its 1.48-day path tilts 87 degrees from the star's equator, a misalignment called obliquity, causing unpredictable seasons and gravitational strain. This tilt, combined with its proximity, suggests it's being torn apart. A 2020 study in the Astronomical Journal estimates it loses 10 superscript 1 kg of gas per second, a rate that could strip it bare in 200 to 300 million years. Compare that to Jupiter, stable for billions of years. KELT 9b is a fleeting giant. Its star's short life adds urgency. KELT 9 will expand into a red giant in 300 million years, possibly swallowing the planet whole. Could it host life? No, its conditions are too extreme. But its moons, if any, might intrigue us. The climax is KELT 9b's defiance. It persists, a glowing enigma against a star that's both creator and destroyer, pushing planetary science to its limits with every scorching orbit. As of March 2025, KELT 9b blazes on, 670 light-years away in Cygnus, a fiery enigma under intense scrutiny. Since its 2017 discovery by the KELT team, this hottest known exoplanet has drawn the eyes of the world's most advanced telescopes. The Hubble Space Telescope in 2019 captured its glowing hydrogen tail, confirming mass loss at a staggering rate, up to 10 superscript 1 kg per second. Now, the James Webb Space Telescope, JWST, operational since 2021, is peeling back its secrets further. Early JWST data from 2023, published in the Astrophysical Journal Letters, detected titanium oxide and iron vapor in its atmosphere, a first for any planet, painting a picture of a world unraveling in real time. Today's focus is on precision. KELT-9b size, 1.89 Jupiter radii, and mass, 2.9 Jupiter masses, are refined through transit and radial velocity data from TESS and ground-based observatories like HARPS. Its dayside temperature, locked at 4,600 K and nightside at 2,500 K, are mapped with infrared spectroscopy, revealing a stark thermal divide due to tidal locking. Dr. Scott Gaudy, part of the Discovery team, notes, "Every observation adds a layer. It's a planet in flux, and we're watching it dissolve." Challenges persist. Its star, KELT-9, shines at magnitude 7.6, overwhelming the planet's signal, and its 87-degree orbital tilt complicates transit timing. Current trends in exoplanet science favor KELT-9b as a lab for studying ultra-hot Jupiters. Researchers aim to model its atmospheric escape, predicting how long it can endure. The star's UV radiation, 56,000 times Earth's, drives this erosion, but gaps remain. How thick is its atmosphere? Does it retain a core? JWST's next observing cycle in 2025 could answer these, though telescope time is fiercely competitive. KELT-9b stands as a beacon of extremes, pushing our tools and theories to their limits, a testament to how far we've come and how much we still yearn to know. What awaits KELT-9b in the eons ahead? This ultra-hot Jupiter teeters on the brink, its future unfolding in three fiery possibilities. Scenario 1. Stripped to the core. KELT-9b's atmosphere is bleeding away, 10 superscript 1 kg per second, according to Hubble data. In 200 to 300 million years, it could lose its gaseous envelope entirely, leaving a scorched, rocky core, perhaps 5 to 10 Earth masses. Dr. David Singh predicts it might become a naked planet, a relic of what it once was. This hinges on its mass loss rate stabilizing, but the star's intense UV radiation might accelerate the end, transforming it into a Chthonian world, a rare survivor of atmospheric stripping. Scenario 2. Swallowed by a dying star. KELT-9, a blue giant, has just 300 million years left before it balloons into a red giant. At 0.0347 Australian dollars, KELT-9b orbits perilously close, 25 times nearer than Earth to the Sun. As the star expands, it could engulf the planet, vaporizing it in a final blaze. A 2021 study in astronomy and astrophysics gives this a 60% likelihood, noting its orbit might decay inward first due to tidal forces. Dr. Scott Gaudy muses, it's a race. Will it evaporate or be swallowed? Either way, KELT-9b's days are numbered. Scenario 3. A rogue survivor. A slim chance exists, less than 5%, that gravitational perturbations could eject KELT-9b before its star's demise. If flung into interstellar space, it would drift as a rogue planet, its remaining atmosphere freezing in the cosmic cold. This wild card depends on unseen influences, like a passing star, but it's a long shot. Whatever its fate, KELT-9b will illuminate the life cycles of ultra-hot Jupiters, a fleeting flare in the cosmic night.